Hi! Let's look at how laser scanning can help you check floor flatness. It's accurate and efficient, it lets you document the quality, and it lets you identify errors so that you can correct this before the concrete sets. We'll show you how to do the full process from basic scanning to the analysis you can do in the field, as well as more advanced topics like creating automatic reports. We'll visit a bicycle parking basement where users can also wash their bikes. There is a drain and we want to check if everything is as it should be according to regulations. In this case, the basement and the floor are already completed. First, set up the tripod and then mount the scanner. The Trimble X-series scanners are self-leveling and self-calibrating. They are easy to use and you don't need annual service. Take out the tablet and connect it to the scanner. Then start the scan. In this case, we will start with a single scan to check the area close to the drain. It takes about 1 or 2 minutes with the settings you use for this type of work. If you need to do more than one scan to capture a large area, the point clouds will be stitched together in a large point cloud automatically. Now, let's check the results. To check the floor flatness, we use Trimble FieldLink software on the tablet. First, you go to the viewing option ribbon and then choose elevation. Then we set the reference height, which is the elevation, to compare the rest of the floor to. In this case, we choose a point near the drain to check if the water drainage will work well. We set the range to 20 mm as a starting point to get a nice color plot. Then we create a section box to make it easier to see the floor in the analysis. Looking at the results, we can see a low area near the drain, but it's beside it and not around it. We expected the drain to be at the low point and the other areas around to be higher, but that's not the case here. There will be a problem with water accumulation if nothing is done about it. We did a few more scans and we can see other similar issues in the rest of the basement. If you want to document a problem like we have found here, or create documentation that everything is okay, you can do that quite easily. On the tablet, go into floor analysis and then create a new floor. Set the resolution, which is the distance between the reporting points on the floor. Set elevation, which is your 0 point. Finally, set the tolerance. Then we create the results and look at the contours and colors of the different points to see where the issues are. We see the same issues as we discussed earlier, but with this report the elevation results are reported on a specific coordinate, which makes it possible to communicate accurately. You can share the results by generating a report automatically. Another cool thing with having points with accurate coordinates is that you can use the red laser pointer on the laser scanner to point out specific areas. Another opportunity is to use the floor analysis results in Trimble Connect AR. This will let you see the results overlaid over the real world. Some may also want more detailed and advanced functions to handle the point cloud. In that case, we recommend using Trimble RealWorks. To summarize, we set up the scanner with the low density preset and ran a single scan. This gave us 12 million points and it took around 2 minutes from start of the scanning until we had the results. With the Trimble FieldLink software on the tablet, we could display the floor flatness and identify issues very quickly. Then we followed up with more scans to cover the entire floor, creating an automatic report. This let us document our findings. We hope you found this useful. See you later.